Number 1, what is the solution to the system of equations graphed below? Remember, the solution is the point where the two lines intersect, so that would be this point here. Now remember, your point is an xy coordinate, so it's x, comma, y. And we first will look at the x value, so that would be 1, 2, 3. And the y value would be 1, 2, 3, 4. So the point 3, 4 is our solution. Number 2, Books A Million sells new books. Paperback books cost $3. Hardback books sell for $5. The store sold 26 books and made $120 from the sale. How many hardback books did the store sell? So if we think about KNOWS, our nose annotation tool, we want to start with what we know. So I would highlight or just make a note that paperback books cost $3, hardbacks cost $5. There were 26 books sold total and $120 total. Next, what we need is how many hardback books that the store sold. Okay, so we know the green information. We need the number of hardback books that the store sold. And now we want to organize and write our work out. Okay, so to organize this information, we want to know something about the cost or the money involved with the books, and then something about the number of the books total. So those are the two different things going on here. So we have $3 per paperback book, and then $5 per hardback, for a total of $120. Then as far as the amount of books, there were 26 books total. Okay, now as we write our equations and work this out, what's really important here is to notice what your variables are. Okay, so as we write these equations, we need to assign something to our variables. So we have paperback books and hardback books. Okay, paperbacks can be our X, and hardback can be Y. Right, so $3 per paperback plus $5 per hardback was a total of $120. Then the number of paperback plus the number of hardback was a total of 26 books. Now we need to find how many hardback books that is. So we need to find the solution. Okay, now the number of hardback books, that is Y. So we really need to find the number of hardback books, which is the Y value of the solution. So when I type in these equations, 3x plus 5y equals 120, and x plus y equals 26. I'm looking for the point of intersection. So I don't see it here. I need to zoom out some and then zoom in on that intersection between my two lines, and that gives me the point 521. Okay, so my solution is the point 521. But I need to break that down and see how that translates to what I needed to know, what question I needed to answer. Remember that X represented the number of paperback books, and Y represented the number of hardback books. We wanted to know, or we needed to know, the number of hardback books. So that would be the Y value, which is 21. Okay, number 3. The cost for a breakfast burrito and a small glass of juice is $3.25. The cost for 3 breakfast burritos and 2 small glasses of juice is $8.50. Define your variables and write a system of equations that represents the given scenario. Okay, so we have a breakfast burrito and a small glass of juice is $3.25. So to define our variables, they're the two things that we don't know. We don't know the cost of just one breakfast burrito or the cost of one small glass of juice. So we're going to let X equal the cost of a breakfast burrito, and Y can represent the cost of a small glass of juice. So far what we know is that X plus Y equals $3.25. Okay, the cost for 3 breakfast burritos, so 3X plus 2 small glasses of juice, so 2Y equals $8.50. So those would be our two equations. Number 4. How many solutions does the following system of equations have? Okay, remember a solution is any time your two graphs overlap one another. So there's a intersection and there's an intersection. So those 2 points of intersection are your two solutions. All right, now number 5. I'm going to move this out of our way so I can zoom in some. Okay, 2 times Carla's age plus Jace's age equals 50. Carla's age is 2 times Jace's age. How old is Carla? Okay, so what we know is pretty much everything that's written here. What we need to know is how old is Carla. So that's what we need, is how old is Carla? What is her age? Now to organize some of this information we have, that's going to require us to identify our variables. So define what is X and what is Y. So I would say just by reading this, to define our variables, X and Y, 2 times Carla's age. So we don't know Carla's age, so we're going to let that be X. And Jace's age can be Y. Okay. Now we need to write our equations. All right, so we have 2 times Carla's age, so that's 2X, plus Jace's age, which is Y, is 50. Then it says Carla's age, which is X, is, so equals, 2 times Jace's age, so 2 times Y. How old is Carla? So now we need to find our solution. So our solution is going to be the intersection point when we graph these two equations. All right, so that's 2X plus Y equals 50, and X equals 2Y. Okay, I need to zoom out so I can find my two lines, and where they intersect is at the point 2010. Okay, now we need to think about how does the solution fit with what we needed to know. Okay, we need how old is Carla. Well, X represented Carla's age, and Y represented Jace's age, and we needed to know Carla's age. So Carla is 20. Okay, number 6. Kate bought 5 pieces of bubble gum and 3 candies for $4.25. Jordan bought 8 pieces of bubble gum and 2 candies for $5.40 at the same store. What is the cost of 1 piece of bubble gum? Okay, so the information that we know is already given to us. What we need is the cost of 1 piece of bubble gum. All right, so to organize this information, okay, we need to know x equals something and y equals something. So x is which unknown value? Well, we don't know the price of bubble gum, so we can let x equal the cost of bubble gum. And we can let y be the cost of candy because we don't know the cost of candy. All right, so now to organize this a little bit more, what we need to know is that Kate bought 5 pieces of bubble gum, so that would be 5 bubble gum, plus she bought 3 candies for a total of $4.25. Okay, and then we know that Jordan bought 8 pieces of bubble gum. I'm going to abbreviate for BG for bubble gum, plus 2 candies, so 2 candies, for a total of $5.40. Okay. Now we need to write our 2 equations. So to write our 2 equations here, that would be 2 bubble gums, so 2x, plus 3 candies would be 3y equals $4.25. And 8 bubble gums plus 3 candies is $5.40. Then we need to find that solution. Okay, so our solution is going to be the point where these lines intersect. All right, so I'm going to zoom in here so that I can see where my 2 lines cross one another. Whoops, it looks like I have written something wrong. Oh, it was 2 candies, not 3 right here. My fault. Let's edit that. There we go. Still not right. What in the world? Okay. Sorry, we had 5 bubble gums and 3 candies, 8 bubble gums and 2 candies. There we go. So that needs to be a 5. I'm not sure where those other numbers came from. Okay. Now, when I look at those intersections, I see something that looks a little bit more like money. So this looks a little more promising. All right, so our solution is 0.55, 0.5. Now, when I turn this into money, that is 50 cents or 55 cents, right? Well, we wanted to find the price of a piece of bubble gum. Well, bubble gum was X, so that's the cost of bubble gum, and Y was the cost of candy. So 1 piece of bubble gum is 55 cents. All right, number 7, match the following system of equations with the correct solution type. All right, so for number 7, we are simply going to, I'm going to draw a line to box this off, so this goes with the other equation. Number 7, we are just going to type these into Desmos and see, do they cross once, none, or are they the same line? All right, so negative 2x plus 3y equals 6, and x minus 3y equals 5. All right, I can't see all of that, so I'm going to zoom out nice and wide so I can see that these cross one time. Okay, so this system has one solution because they cross one time. All right, the second one, 2x minus 4y equals 20. 4x minus 8y equals 40. Okay, now if you'll notice, I'm going to turn the black line off so we can see the purple line, and then when I graph the second line, it's right on top of that. So that would be infinitely many solutions. Now it may not match up just like this. It looks like the last one is obviously going to be no solution, but we're going to check it anyway. All right, so 3x plus y equals 12, and 2y equals negative 6x plus 12. Oops. All right, so now as I zoom out on these, it looks like they are parallel lines, so they have no solution because they do not intersect. Okay, number 8. Daquan and Xander are selling pies for a school fundraiser. Customers can buy pecan pies and cherry pies. Daquan sold 7 pecan pies and 3 cherry pies for a total of $84. Xander sold 3 pecan pies and 6 cherry pies for a total of $69. Xander wrote a system of equations to represent their sales. Identify what mistake Xander made, correct the mistake, and find the correct price of pecan pies. All right, so we know everything that's given to us there, and what we need is to find the price of a pecan pie, right? Find the price of pecan pies. I'll do this in a different color. All right, well, that's what we need. Now we want to organize and work this out. We're going to check our work with Xander's work as we go. So first we need to know what is x and what is y. Okay, well we have pecan pies and cherry pies. So I would say pecan pies are going to be x, so that would be the number of, that would be the cost of pecan pies, because we already know how many they sold of each kind. What we don't know is the price of each kind. All right, so x is going to be the price of pecan pie and y is going to be the cost of cherry pie. All right, so some more information that we know is that for Daquan, he sold 7 pecan pies, so 7x, plus 3 cherry pies, so 3y, for a total of $84. And then Xander sold 3 pecan pies, so 3x, plus 6 cherry pies, so 6y, for a total of $69. All right, now we want to work this out. So our work is going to be typing this into Desmos and then finding the point where the two lines cross. So we're going to type in our two equations, and we're going to look for where those two lines cross one another. Okay? All right, so I'm going to have to zoom out some and then zoom back in. So we have the point for our solution, 9.7. Okay, but remember that we needed the price of a pecan pie. All right, so the price of a pecan pie, remember pecan was x, So 1 pecan pie is $9. All right, now this has pretty much done the work for us. As we find the mistake that Xander made, or we're looking at our equations, we can see that his mistake was right here. He got his x and y mixed up. Okay, so 3 pecan pies would be 3x, and 6 cherry pies would be 6y. So that was one mistake he made. And then the correct price of pecan pies is actually $9. Okay, number 9. Bella bought 5 tickets to a movie, where adult tickets cost $12 and child tickets cost $8. She spent a total of $52. Which system of equations will determine the number of adult tickets, A, and the number of child tickets, S, Bella purchased? Okay, I would actually let A be X and child tickets, S, be Y. All right, so if Bella bought 5 tickets total, well, first we know that there are 5 tickets total. Adults are 12, children are 8. She spent a total of $52. So that is what we know. Okay. What we need to know is the number of adult tickets, we're going to let that be X, and the number of child tickets. Okay. Now we need to organize this information. All right, so there were 5 tickets total. And adult tickets cost $12. Child tickets, which is Y, is $8. And the total number of, or the total cost was $52. Okay, now so to write our equations. Using this information, 5 tickets total means that the number of tickets for adults and children added together was 5. So x plus 5 equals, x plus y equals 5. And we know that the costs all added up to $52. So $12 per adult plus $8 per child is the number of $52 total. All right, so our solution is just going to be, since we're looking for adult and child tickets, our solution is going to be the x and the y value. So we're going to graph these. It's not asking us for this precisely, but it is asking us which system we would need to type in. So based on the answer choices that we have, x plus y equals 5, and 12x plus 8y equals 52. So that would have to be C. Okay, now our solution, if we were asked to find the solution, it would be the point where those 2 lines intersect. But we were not asked to actually solve this problem. Number 10, what is the solution to the system of equations? All right, well, we just need to type these into Desmos and see what we get. Negative 4 equals x minus 4y, and negative 2x equals, negative 2x plus 3y equals 6y. I misspoke again, excuse me. Negative 2x plus 3x equals 6y. All right, so at first it looks like it might be no solution because they're not intersecting in the screen that's visible, but if I zoom out and zoom back in, I see that my solution is negative 12, negative 2. So that is where these two lines cross. Number 11, a group of 15 people, adults and students, went to a museum for a field trip. Each adult paid $10 and each student paid $7. Altogether, the group paid $117. Write a system of equations to find the number of adults, x, and the number of students, y, that went to the museum. Okay, so what we know is everything that's already given to us. What we need is to write a system of equations. So that's really all we need to do for this one. And to organize this information that we were given, we need to define our variables, which is already done for us. And then we just need to put these equations with those variables, or those values with those variables. So they're a group of 15 people total. Okay. Let's see. Adults pay $10. So I'm going to make that a little bullet point. Adults, which is X, is $10. Students, which is Y, costs $7. And the total amount of money was $117. Okay, so our next part is just to write our equations. So based on the adult tickets costing $10 plus the students' tickets costing $7, that total amount of money was $117. Okay, so one equation needs to be for the money. All right, so as far as the cost, it was $10 per adult plus $7 per student for a total of $117. So that one's all about the money. Then we have an equation all about the total number of people. So X adults plus Y students is a total of 15 people. So that system of equations would be, let's see, X plus Y equals 15, 10X plus 7Y equals 117. That would be B. Number 12. A system of equations is shown. What is the value of X plus Y? So what we need to do here is find X, find Y, and add them together. All right, so we're going to graph these to find the solution. Okay, so that's going to be our first thing that we do. And then we're going to add X plus Y. Oops. All right, so step one, we need to graph these and find that intersection. So negative 3X plus 4Y equals 13. And 2X plus Y equals 6. Okay. Our intersection is at the point 1, 4. So our solution is 1, 4. And to add them together, we're going to do 1 plus 4, which gives us 5. Number 13. A system of equations is shown. What is the value of X in the solution to the system? So we're just looking for x. Okay, so when we find x comma y, we're just looking for the x value. Okay, so we have y equals negative 2x plus 5 and 3x minus 5y equals 14. Right, so when I look at that intersection point, I'm going to zoom in on the point where the two lines intersect. So that's 3, negative 1. What is the x value of that? Well, this is x, this is y, and we wanted to know x, which is 3. If a system of equations has infinitely many solutions, what does the graph look like? Okay, well, infinitely many solutions means that they have all points in common. So if they have all of the same points, then they have to be the same line. So that means when you graph it, you have one line and then you graph and another line goes right over top of it. Number 15, select the coordinate point that is a solution to the system of equations given. So we're going to graph these. Negative 6x plus 8y equals 48. Whoops. Equals 48. And negative 3x plus 9y equals 54. Alright, so I can't see my graph. I need to zoom out quite a bit. And then where the blue line and the red line overlap, where they intersect, is at the point 0, 6. Right, so my two lines look something like this. They intersect at the point 0, 6. Right, number 16. Reserved seat tickets for the basketball game cost $9 each, and general admission tickets cost $7 each. After the game is over, the attendance count shows 500 people watched the game. The total ticket sales were $3,796. How many reserved tickets were sold at the basketball game? Okay, well, what we know is all the information that is given to us, and what we need to know is how many reserved tickets. That is what we need. So that's going to be one of our variables. Okay, so now we want to organize some of this information. Okay. All right, so there are reserved seat tickets. We're going to let that be X. And there are general admission tickets. We're going to let that be Y. Okay, so what we know is that $9 for reserved tickets. So I'm going to say $9 for reserved plus $7 for general admission was a total of how much money? So that was $3,796. Then we have some money about how many people total there were, so, or how many tickets total. So then reserved plus the general admission was a total of 500 tickets. And that's where our two equations are going to come from. Okay, so that would be 9x plus 7y equals 3796. And then x plus y equals 500. All right, so we need to find that solution point. All right, I'm going to have to zoom out quite a bit here because we're up in the 500s at least. X plus y equals 500. So my solution point let's see, I'll have to go down here some. So my solution point is 148, 352. Okay, so this is my XY. Well, the question was asking me to find the number of reserved tickets. So reserved, we said that that was X. So our number of reserved tickets is 148. Okay, number 17. Some values for two linear equations are shown in the tables below. What is the solution to the system of equations represented by the two tables? Okay, so the solution, think about what solution means. Okay, the solution is the point that the two lines have in common. Okay, so when you are talking about an intersection, just taking the last example, or the last problem, for example, that point is on both lines. So looking at a table, you're looking for the same thing. Where do each of these tables have the same point? Okay, well, they both have the point -1, -3. So since they both have that point, that is the solution because that is the point that they have in common. That would be the intersection point. And finally, number 18, how many solutions does the following system have? So these two lines, let's see if I can trace over them a little bit. So there's this line that's a quadratic. It's the U-shaped graph. And then we have just a straight line here. And they're pretty close to one another, but they do not intersect. Okay? So since they don't intersect, there are no solutions. There is no intersection.